I'm glad you mentioned digital twins. Can you give a brief explanation of what that term means? I realize it's probably something to do with like a simulation in a digital environment. Is there more to it than that?
Well, I've just, to me, it's simulating the entire thing, not just the sixed off simulation of the aircraft flying, but the sustainment capabilities of the aircraft, how you would sustain it, all the way down to engine performance and details of engine performance. So your twin can get higher and higher fidelity as you go along. But there's also a term called digital shadow, which I learned a couple of years ago, which is essentially a twin that doesn't receive any information from the aircraft. So that's another side. That's kind of what you're doing up front. You're really building this little shadow up front. Then you build a twin to match the airplane because it gets feedback from the aircraft. It also provides information to the aircraft. So they're both synced up and they're both flying, hopefully doing the same thing when you're testing.
Right.
But the twin is really not just an airplane model, but the whole thing. The entire system of systems model eventually is a twin.
Gotcha. And is that a new capability with digital engineering, or is there something similar that we've had in the past that does or has done what a digital twin can do now?
Parts of it.
Yes, but not that whole holistic view.
Yeah, I don't think so. I mean, if you guys have another opinion, I've seen parts, pieces, components, fatigue analysis. So you can instrument an aircraft, make a fatigue model, and then try and make those match. That's a little twin, a miniature twin of just a fatigue, maybe a wing box. But the full aircraft, the full maintenance schedule, the full sustainment cycle, the full test and evaluation, pre-test and evaluation, and then actual test and evaluation, I haven't seen much of that. I haven't seen it.
No, I concur. What you have seen in the past is glimpses or pieces of that digital twin, not the whole thing, but just a domain-specific perspective of that, right? So, and that's part of the transformation here we talked about. You hear a little bit with MBSD transformation, but with digital engineering transformation, it's all about connecting all those currently independent analyses and bringing that information together. So that way, when you run your sixth off or you run an FEA model, you make a change here on your CAD drawing, how does that impact flow through the rest of your system, right? So connecting all that together brings you to an authoritative source, a single source of truth, so that way everyone's working off the same data, which eliminates a lot of what version are you? Summarizes configuration management, right? Everyone's working off the best known set of data. But yeah, it's in the past, it's always been this domain ran off for 6 months, did this analysis. Oh, by the way, 3 months later, another team ran off and did a separate analysis that's related. And then in the end, we just get reports back, right? And it's up to someone to try and collate these pieces of information together that aren't necessarily set up in a way that they can be directly comparable or joined, right? So that's a big thing, bringing information together in the same or in a linkable format, so that way you just improve decision making and again enable all the automation we've already talked about.
Right. All right, I think we hit that subject pretty well. The next thing I want to talk about is and really I think we've touched on this a little bit too, but to a government customer, we can think outside of the box and talk about commercial customers. Why is digital engineering so important? I know we've hit that few points talking about automation and faster decision making, but what else is there? Is there anything else, I guess, that makes it important for our customers to adopt it soon rather than in a few years or whatever they might be thinking?
Yeah, I'll take that one. I'm going to take a politician's twist and change your question into a subject I want to talk about. So like,
awesome, do it.
Some more buzzwords. So you hear of CIDI, continuous integration, continuous development, DevOps, DevSecOps, Agile, system development, safe, et cetera, right? So all these terms that are very prevalent in software design, software development, right? So they're not new, right? They've been around, I don't know, just 5, 10 years, right? Like it's not new, but what we're currently trying to do is apply it to a hardware software, a complete, complex system, right? So trying to, manage the work in a method, shying away from a waterfall. It's like, okay, here, we've got 9 months, year, 10 years, right? We're going to do this project. We're going to plan it from start to finish and never deviate from that plan, right? So what the automation we've already talked about, those small pieces of connectivity between all these tools, between all the analyses, the data sets. What this allows you to do is you chunk your work into smaller pieces, so you're able to deliver smaller pieces of capability quicker to your customer, right? For us, it's the fleet. But also what that allows you to do is that it's always reoccurring planning, right? So you go off and you spend a short amount of time developing a piece of the capability, right? Strategic enabler. But as you're doing that, things change, right? Budget, financial schedule, politics, whatever, even the mission set, right? The operational area, the threat, either the threat change, new threats, et cetera, right? So as you deliver that capability, you're able to immediately test it, determine how well you met the fleet's need, right? The customer's need. Then you're also, as you go to start the next effort, you're able to look at what has changed. Do I need to increase to decrease performance? Am I still on target? Has the threat envelope changed so much that I just need to abandon this and start something new? So what all this it does to the system engineering process, right? The traditional V, in my opinion, actually starts to become more cyclical, right? It's a circle, and then you actually have all these nodes spiderwebbing across each other. So you create all these connections. So I do an initial mission analysis, mission engineering up front, JSIDS process. I do an assessment against the mission. I find my capability gaps. I go forth and get requirements, and then I start the acquisition process. But what that doesn't do, we talk about it in system engineering, in academics, the feedback loops, right? And yeah, you kind of do that, but there's no true real feedback. Like I can't be in the middle of functional decomposition, and you've got some loose traceability back to your CDD, but if that high level mission analysis change, if that capability gap change, I don't have a great way of determining whether or not the function I just wrote down at system level is still going to be adequate, right? So what digital engineering does enable, it's able to connect through, the terms digital threads, some other connectivity, but you're able to actually monitor that, right? So it's like I pass this function, these sets of functions are enabling this capability is enabling this gap. But that gap, the parameters on it changed. Now, do I need to change my requirements? Or I fail my requirements down here, do I still meet the capability gap? So you're able to you don't have to wait to DT to OT, the V and V phases, right? So lab all the way up to your customer operating the system, right? So you're able to inform that all the way back and also monitor that operate. So I mean, like classic DoD, right? Delivering a major weapon system. By the time you start, the time you finish, we're talking 10, 15 years, right? And so now we're delivering this new capability to the fleet. And it's already 15 years old, right? And maybe running Windows XP, right? And it's just kind of like, what are we doing here, right? But now we got to start the ECP process to, all right, it's XP, so let's go to ME first, right? And then we just slowly crawl our way up, right? So it may not prevent that, but it at least enables the decision makers, to consciously decide whether or not they're going to modify course, change plans, right? In smaller chunks to hopefully enable, the right capability getting to the fleet sooner.
Go, Casey.
No, I think John pretty much nailed it there. Kind of going back to the analogy, like I take a look at, digital engineering, digitally integrated environments, and I feel like you're taking a step back from the system engineering process and you're really optimizing it, right? And how we're optimizing it is through connecting a bunch of virtual tools, connecting to each other. Our information, our data is all interconnected, which in return goes back to what John was saying. It's a faster feedback loop. We have access to the information quicker. We can essentially set it up one time, do the hard work one time, and we can continuously run that analysis based on feedback that's given from our system. So I think John pretty much nailed it there.
I'll just summarize and say that I think the concept, the question I always get from potential customers or guys I know working in the industry is, are you seeing much faster turnaround times? The answer is no, we're not there yet, but we are seeing less errors. So this is supposed to really limit errors, improve your product, quality. And then as we get better and better at this, the time should shrink. And hopefully instead of 15 or 20 years, we do 5 years for aircraft design. So we're not there yet. Maybe 2 or 3 cycles of this. We'll get better as we go. So reduce errors and then reduce time. I think that's the best. That's what you should expect from doing this kind of work.
Yeah. So you guys are actually I'm going to hire you guys marketers because you're hitting all of those terms that we try to hit in some of these episodes. So reducing risk, errors, saving time, saving money in turn, making the decisions faster. So yeah, all of those points are great. And if I was a customer, I'd buy from you guys. Thanks for watching this episode of the Model Vision podcast. On the next episode, we'll continue this conversation about digital engineering and what exactly that is for us, for our customers, and for anybody that might be interested in the world of digital engineering. This episode is cut up into 3 sections, so be sure to watch over the next couple of weeks as we finish out this conversation. John, and Casey are all in these next few parts, and they get more in depth into what digital engineering is, what it means for you, and what it means for potential customers in the future. If you want to learn more about digital engineering, you can visit avian.com/digital engineering. That's avian.com/digital-engineering. Thank you again for watching the Model Vision podcast. I'll see you guys next time.